We've got showing here a type curve analysis plot where a type curve is well, essentially it's the dimensionless representation of an analytical solution of a reservoir description using dimensionless parameters typically shown on a log-log plot, as we can see here. And the idea is that if we can fit a type curve through the data, that this may give us an indication of what the reservoir description would look like, contingent that we know something about the well reservoir geometry to begin with. The flowing material balance analysis, which is the first of the straight line techniques to the bottom left-hand corner here, this gives us an indication of contacted volume in place for unconventionals. For conventionals, this would give you a very good idea of OOIP or OGIP. For unconventionals, it's a moving target. As the data updates, it keeps projecting to a larger volume. Usually our interpretation is that off the flush production for a shale well, we would indicate that is what we would call an SRV as we stretch our use of the language a little bit. But that's a fairly useful tool and fairly commonly adopted at this point in time. The linear flow specialized plot comes in many shapes and forms, from square root time plot analysis, which is just 1 over Q versus square root time, to a normalized like delta P over Q versus square root time, to more sophisticated time functions. You're seeing an example of that here. But really what it is to diagnose flow regime to make sure that we're seeing most likely linear flow from any fractured well to start, and then a transition. And it's in that transition that we really start to do our interpretation and infer what's going on. The linear flow specialized plot values can be used to characterize completion effectiveness, which I'm going to get into shortly.